right, now we are ready to write on them, okay? Great. All right, so cool. We're just going to continue on today. It's kind of actually kind of similar to what we were doing last week. We're kind of putting these two ideas together. So we have 2.02 here, simplifying rational exponents. So here's our steps here at the top. So first of all, you want to always convert roots into fractional exponents. The fractional exponents or rational exponents is what we want, okay? So we see here everything's already given in fractional exponents in these first four. We're going to see some coming up. I can even scroll down here where they give it to you in roots. We're going to be switching those into fractional exponents. So that's step one. Always convert that to fractional exponents, okay? Step two, if we have two of the same bases multiplying, just like we did before, we're going to add the exponents, okay? Add the exponents. Now, what's going to be trickier now is that they're going to be fractions. We need to remember, when we add fractions, we need common denominator, right? That's another big thing we talked about last week. All right, if it's one base with two exponents, with one of them outside of parentheses, we're still going to multiply. So again, we did that last week, but now we're going to do it with fractions, which means we do not need common denominator to multiply fractions, okay? Lastly, same base dividing, we're going to battle, and we are going to need common denominator for that, okay? So let's jump into it here. Let's do these first few together. Okay, so we have number one here. We have m to the 1/4 power times m to the 3/2 power. So we need to add those exponents, right? When we have two bases multiplying, we add the exponents. So I can't add this in my head. I'm not going to try. We're going to go over here, and we're going to do 1/4 plus 3/2. We know that when we are adding fractions, we need a common denominator. So is there a number I could turn these both into very easily? Or I'm going to multiply by 2 to make them both 4, right? Okay, so I'm going to multiply this one by 2. So that's going to give me 1/4 plus 6/4. Whenever you multiply the numerator by 2, you have to, or by whatever, you have to multiply the denominator by that same amount. Now that I have the common denominator, we add together the numerators, and then the denominator stays the same. Okay? Nunca cambia el denominator común. Okay? The common denominator never changes. Now our answer here is not really 7/4. Our answer is actually m to the power of 7/4. So that calculation that we did there is just telling us what our new exponent is going to be. So the 7/4 on its own is not our answer. It's m to the power of 7/4, okay? All right, next up over here, number 2. Otra vez, we need to add the exponents together. I kind of already know, because this 3 has nothing to multiply by. Like, my answer is going to be 3k to some power. But now I'm going to do this common denominator over here to figure out what that power is, okay? But I already know that that 3 is just going to kind of stay out front. I'm going to have a k there to some power. We just need to figure out what the power is, okay? All right, so let's do this. We are going to get a common denominator with these two fractions. I don't think I can turn the smaller one into the bigger one this time. We can't multiply 3 by anything to turn it into 4. So in this case, we have to multiply both of them by the other denominator, okay? So this one's going to get multiplied by 4. This one's going to get multiplied by 3. So in these cases, where I can't just multiply to turn one into the other, I multiply both of them by the other denominator, okay? So then we can see here, this is going to be 8/12 plus 15/12. We got that common denominator that we wanted. The 12 is on the denominator of both of those. Once we have the common denominator, we add the numerators and keep the common denominator the same. So there's a 12 on bottom. And what's 8 plus 15? 23. Can we reduce 23 over 12? No. I don't know. 23, can't divide by anything. So I'm not going to be able to reduce that, okay? So then my answer is going to be 3 times k to the power of 23 over 12. So the hard part is adding those fractions together, but remember that's not your answer. That is just the exponent, okay? The exponent of your answer. All right. Let's go ahead and scroll down here. And let's do number 3 together, and then I'll have you guys try out number 4. All right, so number 3, first of all, we have two kind of big regular numbers there, right? You see the big 3 and the big 2. So we're going to multiply those together and get 6. So remember the big regular numbers, we do not add, we multiply them. It's the exponents that we add. So I'm going to have here 1 over 2 plus 3 over 2. This is me adding the exponents. Of course, when we add exponents or add fractions, we need common denominator. But good news, I already have common denominator. So I just keep the denominator the same, add the numerators. Does this one reduce? Yes, actually it does. This is actually just 2, right? 4 divided by 2 is just 2. So this will be 6p to the power of 2. All right. Cool. So next up, let's have you guys try out number 4, okay? Let's have you guys try out number 4. Ready, go. All right. So I got 2 times 2 is 4. And then v to the power of, I had to add the exponents together. 5 over 3 plus 5 over 3, give me 10 over 3. All right. Awesome. All right, let's continue on here. Number 5 and 6, probably very more similar to numbers 1 and 2. Okay. So look back at what we did on numbers 1 and 2, and you guys try out numbers 5 and 6 now. Ready, go. 5 and 6. We'll go over them in 1 minute. right, number 5 there, I got 4n to the power of 13 over 12. You can see my work there with the common denominator. Uh-oh, that's not right. All right, so for number 6, I got x to the power of 11 over 6. Sound good? Hey, yeah, good job. Everyone who's in here is looks like they're really getting this. Just got to put together a couple pieces of what we learned last week, okay? Really good job. If you've been with us here, shouldn't be too bad, okay? All right, numbers 7 and 8, we're going to switch things up a little bit here. It's actually not a lot, though. So the only difference with number 7 and 8 is that the questions are given to you as radicals, okay? So what I said at the top of this page of notes was that whenever this happens, I would just say your first step would be to change it to the fractional exponents, okay? Once we do that, then it just turns into like number 5 or 6, okay? So how do we turn this into fractional exponents? Recuerdan ustedes, remember that the numerator is the power and the denominator is the root, okay? So whatever's inside the root, that's your denominator. Whatever is showing up as an exponent is the numerator. So then what's this one over here? I'd say that that's got to be 3/4. Okay, so now the bases are multiplying, so we are going to add the exponents. So 2 over 3 plus 3 over 4. Necesitamos denominator común. So we're going to multiply by the other denominator because the 4 and the 3 have nothing in common. So I get 8 over 12 plus 9 over 12, 17 over 12. Very good. So my answer is going to be x to the power of 17 over 12. All right, next up here, number 8. First off, we switch this to x to the power of 5 over. So you'll have to remember what happens when there's no number in there, okay? We did talk about this last week, and we said if there's no number in the root, that means it's a square root, and so a square root is going to be 2. No, this is number 8 now. Sorry. Yeah, thank you all. Here I'll switch the colors. I'll make it clear. Thank you, Walter. All right, so this one here, it'll be x to the power of 5 over 2. Once again, it's a 2 on bottom. Anytime there's a root that's empty, that's a square root, and square root is 2. Next up here, I get x to the power of 2 over 6. Wait a minute, can we reduce 2 over 6? Yes. Oh, should we though? It'll work either way. Do I want you to do that? I actually think no. I just think it's going to be easier if we don't reduce it. And I'll show you why right now. Because our next step then is going to be to add these together, right? Is 5 over 2 plus 2 over 6. And can I turn 2 into 6 with just multiplying? Yes, okay? So I kind of saw that ahead of time. If you did reduce that to 1 over 3 and then did the problem like that, are you going to end up with the same answer if you do it right? Yes, okay? So if you do reduce something, that's okay. But if you can kind of think ahead to what you're doing next, it might make it easier actually if you don't. So let's go ahead and do that then. So we're going to multiply this one by 3 over 3 because I want to turn this into a 6. This one's already a 6. So I get 17 over 6. Remember, that's just my exponent for x, so my final answer here is going to be x to the power of 17 over 6. All right. All right, let's continue to page 2. Once again, I am recording this here, so if you have any, or if you missed any, I'll post that after school today, and you can check it out. Okay, now we're going to kind of switch gears here. So now we have one base with 2 exponents, okay? With the parentheses, we got an exponent on the inside and an exponent on the outside. So what's going to change here is that these fractions are no longer going to be adding, okay? It's adding if we have 2 of the same base multiplying. Now when it's one base with 2 exponents, this is where we multiply the exponents, okay? So this one is multiply. So in this case, on number 9, all we're going to do is multiply those exponents together. Should be pretty easy. You just got to remember our rules. So for multiplication, do we need a common denominator? The answer is no, okay? Multiplication is kind of actually easier than addition because you do not need a common denominator. Are you allowed to cross cancel? Yes, you're allowed to. Can I cross cancel a 3 with a 4? No. A 3 with a 2? No. So in this case, we cannot. So that's not a big deal. We just do top times top up top, bottom times bottom on bottom. You can check again, can I reduce it now? The answer is still no. Okay, 9 over 8 does not reduce. So that is my new exponent of m. M to the power of 9 over 8. All right, why don't you guys try out number 10? You can do it. I believe in you. We'll go over it in 30 seconds. All right, so we just had to multiply those exponents, 5 over 4 times 1 over 3. We do not need a common denominator to multiply. We could cross cancel, but nothing cross cancels in this case. So just top times top up top, bottom times bottom on bottom, done. Is anything gonna cross cancel ever? All right. Let's do number 11 really quick. It's no fun because it doesn't cross cancel. I want some cross canceling here. Number 12 will. All right, no cross canceling available. So top times top of top, bottom times bottom on bottom. And we get x to the power of 21 over 8. All right, number 12, now we're going to multiply here. And watch this one because this is a very common mistake that a lot of people make, so I don't want you guys to make this mistake. When we're multiplying this one, it's going to be 3 over 4 times, and then I'm going to write this one as 2 over 1. Anytime you have an integer, a non-fraction, okay, I would always write it as over 1 when I'm dealing with other fractions. A lot of people do this like 2 over 2, like they multiply the top by 2 and the bottom by 2. Don't do that, okay? 2 is just 2 over 1. All right, so if we have that, can we cross cancel here? Yes, finally. All right, we can turn that one into a 1 and that one into a 2. We can divide them both by 2. And so now I just do top times top up top, bottom times bottom on bottom. Remember, I do not need a common denominator because I'm still multiplying. And so my answer here is going to be n to the power of 3 over 2. All right, still not too bad, right? Okay, we're going to change it up again a little bit, but not a lot. We're going to look now at 13 and 14. So now we just have an extra step here, which is we have roots now. So remember, we want to just change the roots and write them as fractional exponents. So this one is going to be x to the power of 3 over 4 to the power of 5 over 3. Todavía estamos multiplicando los exponentes. We're still multiplying the exponents because we have one base with two exponents. So 3 over 4 times 5 over 3. Can we cross cancel here? You're gosh darn right we can. Turn those both into 1s. Or you can just cancel them out. That's fine too, if it's the exact same number. All right, top times top on top, bottom times bottom on bottom. And so my final answer is x to the power of 5 over 4. All right, why don't you guys try number 14 now on your own. I'll give you 1 minute and then we'll go over it. Okay, so I switched that to x to the power of 4 over 3 on the inside, but still the 3 over 2 on the outside. Then we're going to multiply those fractions together. Do a little cross canceling here. We can also cross cancel this way. So the 3's cross canceled to 1's. The 4 and the 2 cross canceled to a 2 up here and a 1 down there. So now top times top up top, bottom times bottom on bottom. So we should have 2 over 1, which I would just write as x to the power of 2. Awesome. Okay. Next up, let's go down here. So now we're doing kind of dividing here. So this one is the one where we're going to battle, okay? It's time for the war, la guerra, okay? So we have to decide who has more troops, and then we have to subtract them to figure out how much they win by. Now, whenever we're subtracting fractions, we need a common denominator. So I would make this a common denominator right now, and then see who has more troops, the top and the bottom, okay? So I look at these numbers. We have a 3 on this denominator and a 2 on that one. So I'm going to turn them both into 6, right? I'm going to multiply each of them by the other denominator. And I'm going to rewrite it like this. v to the power of 14 over 6 up top, v to the power of 9 over 6 on bottom. So now we have the common denominators, so now it's easier to compare them. So who has more troops, the top or the bottom? It's clearly the top now, right? Now that they're both over 6, we can see that the top has more. So the top's going to win the battle. And how much does it win by? Well, if we subtract these two, they already have the common denominator. So I get 5 over 6. So that's ending up on top. Wait a minute, Mr. Berry, I don't even see a bottom anymore, right? Well, technically this is over 1. But if it's over 1, we don't need to write that. We just kind of write what's on top, okay? So if the top wins, you kind of just write the top. All right, let's move it along here to number 16. So for this one, I actually see we are going to battle, but before we battle, can we combine forces with these guys? Yes. If they're on the same level, I'm going to combine their forces first of all. So we have 1 over 3 plus 2 over 3. They're going to add together because they're on the same level. That's 3 over 3, which is 1, right? Actually, I'm going to write that as 1 over 1. And the reason why I'm going to write it as 1 over 1 is I need to make these have a common denominator. In order to see which one is bigger, I need a common denominator. Can I turn the smaller one into the bigger one? Can I turn 1 into 4? Yes. I'm just going to multiply it by 4 on top and bottom, right? So that becomes n to the power of 5 over 4 over n to the power of 4 over 4. Who wins the battle? I'd say the top wins. How much did they win by? We got 5 over 4 minus 4 over 4. Well, not 1, 1 over 4. Okay, I know what you're thinking. The 5 minus 4 is 1, right? But it is over 4. So 1/4. All right, almost done here, guys. Stick with me. You're doing great. Appreciate your participation and paying attention today. Just about 5 minutes left, and then we'll wrap it up, okay? All right. And all we have, okay, cool. Dude, I don't want to do that one. All right, let's skip number 17. Let's go into number 18 here. All right, so number 18, we throw another wrinkle in here because we have the 4s on top and bottom. So the 4s, you just reduce those like a fraction. So 4 over 4, that's just 1 over 1, right? Okay. So now I'm going to get the common denominator here. So can I turn the smaller one into the bigger one? Can I turn 2 into 4? Yes, I can. Who's going to win the battle? The top is. How much did it win by? 1/4 again. Should have made one where the bottom wins. I hate it when one side's always winning. I like it even. All right, let's do 2 more, and then we'll be done for the day, okay? Once again, thanks for sticking with me, guys. So just like we've done on all these other ones, what's up? Oh, sorry. Just like we've done on all these other ones, we're gonna, oh, sorry, something caught in my throat. I'm gonna translate these into the fractional exponents first. So this one will become the 7 over 4 power This one will become the 3/2 power. Once again, we know that when the root is blank, that's a square root, so it's going to be a 2. All right, let's make a common denominator. Can I turn 2 into 4? Yes. Multiply it by 2/2. So I get x to the 7/4 over x to the 6/4. The top is going to win again. Mr. Berry's sad because I want the bottom to win one of these, but it didn't. The top one, it was x to the 1/4. All right, and one more here. Get x to the 5/3, x to the 5/6. I can turn the smaller one into the bigger one. X to the 10/6 over x to the 5/6. So once again, the top wins by 10, nope, by 5/6, excuse me. Awesome. Okay, so I think that's good for today. Like I said, if you missed anything, I'm going to post this on Schoology this afternoon. Please do not turn in your notes yet today, okay? Tomorrow you can see we have